Ladies and gentlemen, what if everything around us is not truly real? What if the stars above, the oceans below, and even our own thoughts are part of a giant simulation created by an advanced intelligence? It sounds like science fiction, yet some scientists and philosophers have seriously explored this possibility. The idea of a fake universe has become one of the most fascinating and unsettling discussions of our time. But what happened when scientists attempted to simulate reality itself? The results were more surprising and more disturbing than anyone expected. For decades, humanity has tried to understand how the universe works. Scientists built powerful computers capable of recreating galaxies, black holes, climate systems, and even the birth of stars. These simulations became so detailed that they began to resemble reality almost perfectly. Entire digital universes were created inside machines, governed by mathematical laws and artificial physics. In these virtual worlds, particles moved, structures formed, and lifelike patterns emerged. The more advanced the simulations became, the more one terrifying question appeared. If humans can create simulated realities, could our own universe also be simulated by someone else? Researchers noticed strange similarities between computer systems and the structure of the cosmos. Some studies suggested that space itself may behave like digital information. Others found patterns in quantum physics that resembled processing limits in computer graphics. Even time and matter sometimes appeared to act as if they were generated frame by frame, almost like scenes in a video game. These discoveries pushed scientists to consider a shocking possibility that reality might not be fundamental, but programmed. But the most dramatic moment came when simulations became unpredictable. Scientists created artificial environments designed to mimic early universes. Inside these digital worlds, unexpected structures began forming on their own. Patterns evolved beyond what researchers programmed. In some cases, virtual systems displayed behavior that seemed almost self-aware. The simulations started producing outcomes nobody could fully explain. Instead of simply following instructions, they adapted, changed, and developed complexity in ways that surprised even their creators. This raised deep philosophical questions. If simulated worlds can evolve independently, what separates a fake universe from a real one? If consciousness could someday emerge inside a computer-generated reality, would the beings inside know they were simulated? Perhaps they would believe their world is real just as we believe ours is. The idea became even more frightening when scientists considered the possibility of glitches in reality. Some researchers pointed to mysterious cosmic limitations, strange quantum behavior, and unexplained mathematical boundaries as possible hints of a programmed universe. While there is no proof, the theory continues to grow because modern science increasingly reveals that reality is stranger than anyone imagined. Yet, this idea is not only frightening, it is also inspiring. Whether our universe is real or simulated, our emotions, dreams, struggles, and relationships still matter to us. Love still feels real, pain still feels real, hope still changes lives. Even in a simulated world, human meaning would remain powerful. The simulation theory also forces humanity to confront its own future. As technology advances, humans may eventually create entire artificial universes ourselves. Future civilizations could simulate billions of conscious beings. If that becomes possible, then statistically, simulated realities could outnumber real ones. In that case, the odds that we are living in the original universe may become incredibly small. So, what happened when scientists simulated reality? They discovered something extraordinary. The line between the real and the artificial may not be as clear as we once believed. Their experiments did not simply answer questions. They created new mysteries. They revealed that the universe may be more complex, more intelligent, and more mysterious than humanity ever imagined. Scientists created highly advanced simulations that could recreate galaxies, stars, and virtual universes with realistic physical laws. Scientists have spent decades building powerful computer simulations to better understand how the universe works. At first, these simulations were simple and limited, but as technology advanced, they became incredibly detailed. Researchers began creating virtual models of galaxies, stars, black holes, and even the conditions that existed shortly after the birth of the universe. Using mathematical laws and physics equations, they designed digital environments where matter could move, collide, and evolve almost exactly as it does in reality. These simulations helped scientists study events that would normally take billions of years to observe in space. What shocked researchers most was how realistic these artificial universes became. Some simulations produced structures that looked nearly identical to the cosmic web, seen through powerful telescopes. Galaxies formed naturally, gravity shaped massive clusters, and patterns emerged that closely resembled the real universe. The more accurate the simulations became, the more scientists began asking an uncomfortable question. If humans can already create realistic digital worlds, could a far more advanced civilization create an entire universe that feels completely real to its inhabitants? This idea transformed scientific discussions around reality itself. Simulating the universe no longer seemed impossible. Instead, it opened the door to one of the most fascinating mysteries humanity has ever faced. Some researchers discovered strange similarities between computer systems and the structure of the real universe, leading to the simulation theory idea. As scientists studied the universe more deeply, they began noticing patterns that seemed strangely similar to the way computer systems process information. In physics, especially in quantum mechanics, certain behaviors of particles appeared discrete rather than continuous, almost like pixels on a screen. Instead of smooth transitions, energy and matter often changed in small, fixed steps, which reminded some researchers of digital coding. This raised questions about whether space and time might also be made up of tiny units, rather than being infinitely continuous. Another surprising similarity came from the way the universe seems to follow strict mathematical rules. Just like computer programs operate on algorithms, the cosmos appears to run on precise equations that govern everything from gravity to atomic interactions. Even light and energy follow predictable patterns that can be calculated with high accuracy. Some scientists also pointed out that the universe has physical limits, such as the speed of light, which resemble processing constraints in computational systems. These observations did not prove that the universe is a simulation, but they made the idea more intriguing to explore. The comparison between digital systems and cosmic behavior encouraged researchers to rethink reality, not just as physical matter, but as something that could also be information-based. This shift in thinking opened new debates about whether the universe might function like an enormous, complex computation. Certain digital simulations produced unexpected and complex behaviors that scientists could not fully predict or explain. When scientists began running highly advanced universe simulations, they expected systems to behave strictly according to the rules they programmed. At first, everything followed predictable patterns. Particles interacted, gravity-shaped structures, and energy moved in stable cycles. However, as the simulations grew more complex and the number of interacting elements increased, unexpected behaviors started to appear. Some virtual environments began producing patterns that were not directly coded into the system. These patterns seemed to emerge naturally, as if the simulation was developing its own internal logic beyond the original instructions. In a few experimental cases, simulated particles formed structures that resembled self-organizing systems, similar to lifelike behavior. These systems adapted to changes, responded to environmental shifts, and even optimized their own stability. Scientists were surprised because such complexity was not explicitly designed. It seemed to arise from the interaction of simple rules at a large scale, creating something far more advanced than expected. This phenomenon led researchers to rethink the boundaries between programmed behavior and spontaneous complexity. If a simulation can evolve unpredictable outcomes, it raises the question of whether our own universe might also contain hidden layers of complexity beyond what we currently understand. It suggests that reality, whether simulated or physical, may be capable of generating surprises even its creators did not anticipate. The possibility of a simulated universe raises deep philosophical questions about consciousness, reality, and human existence. The idea of a simulated universe forces humanity to confront deep philosophical questions about existence and awareness. If reality were truly a simulation, then everything we experience, our memories, emotions, and decisions would be part of an engineered system. This leads to a difficult question. Does something become less real just because it is created? For the person experiencing it, the answer might be no. Pain would still hurt, happiness would still feel genuine, and love would still hold meaning, regardless of the origin of the system. This thought experiment also challenges our understanding of consciousness. Scientists and philosophers still do not fully understand how awareness arises from the brain. If consciousness can emerge from biological matter, could it also emerge from digital systems? If so, then simulated beings might not know they are artificial. They would perceive their world as completely real, just as we do. This raises ethical questions about creating conscious simulations and whether such beings would deserve rights or moral consideration. The simulation idea also blurs the line between creator and creation. If our universe has a designer, then we become part of a much larger system whose rules we may never fully understand. It forces us to reconsider our place in existence and whether reality is fixed or constructed. Even if reality were simulated, human emotions, purpose, relationships, and the search for truth would still remain meaningful. Even if the universe were a simulation, it would not necessarily diminish the value of human life. Meaning is not dependent on the origin of reality, but on the experiences within it. People still feel joy when they achieve something, sadness when they lose someone, and hope when they look toward the future. These emotions are real to those who experience them, regardless of whether the underlying system is physical or computational. In this sense, reality is defined more by perception than by construction. This perspective also shifts how humanity views purpose. Instead of focusing only on whether the universe is real or fake, attention turns toward how we live within it. If everything is part of a vast system, then curiosity, learning, and exploration become even more important. The search for truth itself becomes a meaningful journey, even if absolute answers remain out of reach. Science, philosophy, and imagination all play a role in helping humanity understand its place in existence. Furthermore, the simulation idea encourages responsibility. If advanced civilizations could create simulated worlds, it implies that intelligence carries power and ethical duty. How we treat our own creations may reflect how we would want to be treated if we were created ourselves. Ultimately, whether the universe is simulated or not, human meaning, morality, and discovery continue to matter deeply.